The open ocean, a realm of vast and powerful forces.
Imagine plunging into the deepest, darkest corners of the ocean, a world of crushing pressure.
Billions of animals rise from the deep. Strange new creatures. Animals that thrive in impenetrable dark.
A place so alien, scientists once believed life couldn't exist there. Its deepest parts hide a secret that could change everything we know about life.
His aim? To unlock the secrets of the Great Migration. The secrets of the dark side of the ocean.
1. The deep's dark secret. Oxygen without sunlight. What exactly is a dark oxygen? Simply put, it's oxygen made without sunlight, way down in the ocean where it's pitch black. For a long time, the general belief was that nearly all oxygen on Earth came from photosynthesis, the process where plants and algae use sunlight to create it. But scientists have recently discovered oxygen in the deep ocean, thousands of meters below the surface, where sunlight can't reach, challenging the long-held belief that photosynthesis was the primary source of oxygen on Earth. Dark oxygen, however, doesn't rely on sunlight. Instead, it's created by peculiar potato-shaped rocks scattered across the ocean floor called polymetallic nodules. These nodules act like natural batteries, generating electricity that interacts with seawater. This interaction splits water molecules into hydrogen and oxygen through a process called electrolysis. It's a completely different pathway for oxygen production, one that scientists never anticipated finding in the dark depths of the ocean. 2. How did this happen? The discovery of dark oxygen was a happy accident. Back in 2013, a team of scientists led by Andrew Sweetman was studying the Clarion-Clipperton Zone in the Pacific Ocean when they noticed something strange. They were measuring oxygen levels in the water, but instead of seeing the levels drop as expected, they were rising. At first, they questioned their instruments, assuming a malfunction. But despite repeated experiments, even with improved technology years later, confirmed the same surprising results. Oxygen levels were indeed increasing, and it was all happening around these polymetallic nodules. This accidental discovery raised a whole new set of questions. Could these nodules be a hidden source of life in the deep ocean? What does this mean for the creatures living in the low oxygen areas of the ocean? 3. Oxygen minimum zones. Dark oxygen's role in the twilight zone. Enter the oxygen minimum zones. These vast areas of the ocean, mostly found in tropical and subtropical regions, are known for their extremely low oxygen levels. OMZs typically occur between 200 and 1,000 meters below the surface. These zones are created by a combination of factors, including warm surface waters that don't mix well with deeper, colder water, and high levels of decomposing organic matter, which consume oxygen as they break down. In these harsh conditions, most marine life struggles to survive. However, some unique creatures have adapted to thrive in these oxygen-depleted environments. The discovery of dark oxygen suggests that these polymetallic nodules could play a crucial role in supporting this life. 4. The Eastern Tropical Pacific OMZ. The Eastern Tropical Pacific OMZ is a massive region of low oxygen water stretching across a vast expanse of the Pacific Ocean, from the coast of South America westwards towards Central America. It's one of the largest and most well-studied oxygen minimum zones on our planet, covering an area comparable to the size of the continental United States. Unlike some other OMZs, this one is a permanent fixture, though its boundaries and oxygen levels can fluctuate due to ocean currents and upwelling. Several things cause the low oxygen levels in this area. First, the warm surface water in the tropics is lighter than colder water, so it floats on top and doesn't mix well with the deeper water that has more oxygen. Second, the Eastern Tropical Pacific is full of tiny plants called phytoplankton. When these plants die, they sink to the bottom and decompose, which uses up a lot of oxygen. So, with less oxygen coming from the surface and more being used up at the bottom, it creates the perfect conditions for a low oxygen zone, or OMZ. 5. the Arabian Sea OMZ. In contrast to the persistent low oxygen conditions of the eastern tropical Pacific, the Arabian Sea experiences a dramatic seasonal shift in oxygen levels. This fluctuation is driven by the powerful monsoon winds that sweep across the region, influencing ocean currents and nutrient distribution. During the summer monsoon, the winds churn up the water, bringing deep water that's low in oxygen to the surface. This creates a temporary low oxygen zone that grows and shrinks with the seasons. This dramatic shift in oxygen levels makes it a tough place to live, forcing many creatures to move to deeper waters or areas with more oxygen. 6. The Bay of Bengal OMZ. Tucked away in the northeastern Indian Ocean, the Bay of Bengal OMZ is a one-of-a-kind low-oxygen zone. It's shaped by a combination of factors, including massive river runoff and the unique shape of the bay itself. Massive river runoff from major rivers like the Ganges and Brahmaputra carries a heavy load of organic matter into the bay. This organic matter fuels the activity of bacteria, which consume oxygen as they break it down, contributing to the low oxygen conditions in the deeper parts of the bay. The bay's somewhat enclosed shape and relatively shallow depths also make it harder for oxygen-rich water to circulate, making the low oxygen situation even worse. The Bay of Bengal OMZ is also a hotspot for a process called denitrification, where microbes turn nitrate into nitrogen gas. This is important for the Earth's overall nitrogen balance, but it also means less nitrogen is available for other creatures in the bay. 7. Extremophiles defined, thriving in the absence of oxygen. The deep ocean, especially areas like OMZs, might seem like harsh places for life, but they're actually teeming with unique creatures. These special organisms, called extremophiles, have adapted to survive in these tough conditions, where there's very little oxygen. Some of these extremophiles, called anaerobes, don't need any oxygen at all to live. They get their energy through different methods, like breaking down chemicals in their surroundings. Others, known as facultative anaerobes, are more flexible and can use oxygen if it's available, but they can also switch to other methods if it's not. These strange creatures are essential to the deep ocean ecosystem. They play a crucial role in recycling nutrients and keeping the underwater world in balance. The presence of dark oxygen in these OMZs is particularly exciting, as it might be vital for these extremophiles. It could even mean that these zones are more hospitable to life than we previously thought. 8. Masters of adaptation. Life in the OMZs isn't just about getting by, it's about thriving against the odds. These extremophiles have developed an arsenal of unique adaptations that allow them to not only survive, but flourish in these challenging environments. One of their most impressive tricks is their ability to store small amounts of oxygen for later use. This is like having a backup oxygen tank when the surrounding supply runs low. Some deep-sea fish, for example, have special proteins in their blood that can grab onto oxygen and hold it tight, making the most of every molecule. Another survival strategy is to slow down. Many creatures in the OMZs have a slower metabolism, which means their bodies use less energy and need less oxygen. It's like putting your body into energy-saving mode to make the most of what you have. But it doesn't stop there. Some organisms have even evolved special body parts to help them survive. Certain deep-sea fish have extra-large gills, giving them more surface area to absorb oxygen from the water. Others have developed unique organs to help them extract oxygen more efficiently. 9. The vampire squid. In the dark depths of the ocean's oxygen minimum zones, there's a creature that seems right. Out of science fiction, the vampire squid. This ancient animal, sometimes called a living fossil, has lived in the deep ocean for millions of years, and it's got some interesting tricks to survive where there's hardly any oxygen. The vampire squid has a special way of breathing that lets it live in these low oxygen areas. It's like it has a super efficient lung that can pull oxygen out of even the tiniest amounts. Plus, it's not a very active creature, so it doesn't need a lot of energy, which means it doesn't need much oxygen to begin with. This squid also has a unique look. It has big webbed fins that help it glide through the water, kind of like a ghost floating through the air. and it has huge eyes that help it see in the pitch-black darkness. But maybe the most fascinating thing about the vampire squid is that it can make its own light. This glow-in-the-dark ability is called bioluminescence, and it's used for communicating with other vampire squids and scaring off predators. 10. The anglerfish. Another iconic resident of the oxygen minimum zones is the anglerfish, a creature known for its bizarre appearance and unique hunting strategy. This fish has a gaping mouth full of sharp teeth and a glowing lure dangling right in front of it. This lure glows thanks to tiny glowing bacteria living inside it. The glow attracts other fish and creatures, making them an easy meal for the anglerfish. But that's not all. The anglerfish also has a stretchy stomach that allows it to swallow prey much larger than itself, a handy trick when food is hard to find in the deep sea. Its body is also built for the depths, with a flexible skeleton and loose skin that help it handle the intense pressure. 11. The Dumbo octopus. Named after the Disney character Dumbo because of its large, ear-like fins, the Dumbo octopus is one of the most adorable inhabitants of the deep sea. Its gelatinous, almost transparent body helps it move effortlessly through the water, while its wing-like fins allow it to easily navigate the low-oxygen environment. Unlike many deep-sea creatures that struggle with limited oxygen, the Dumbo octopus thrives thanks to its slow metabolism and specialized gills that efficiently extract oxygen from the water. 12. The giant isopod. The giant isopod, a crustacean that lives in OMZs, is like the cockroach of the deep sea, but much, much bigger. Giant isopods are scavengers, which means they eat dead animals that sink to the ocean floor. They have a slow metabolism and can go for long periods without food, sometimes even years. This helps them survive in the deep sea, where food is scarce. They also have a tough outer shell, called an exoskeleton, that protects them from predators and the immense pressure of the deep ocean. This exoskeleton is like a suit of armor, providing protection and helping them conserve moisture in their dry, deep-sea home. When they do find food, giant isopods are surprisingly quick and agile. Their strong legs and sharp claws allow them to tear apart their meals with ease. They also have large eyes that help them find food in the darkness. 13. Zooplankton. While the giant isopod is a large and obvious inhabitant of the OMZs, there's another group of creatures that plays a crucial role: zooplankton. These tiny animals, often too small to see without a microscope, drift through the water and are the foundation of the food web in many parts of the ocean, including the OMZs. Zooplankton are incredibly diverse, including tiny crustaceans, jellyfish babies, and other small critters. They've adapted to the low oxygen levels of the OMZs in clever ways. Some have special ways of breathing that help them get more oxygen from the water, while others have slowed down their bodies to use less energy. Even though they're tiny, zooplankton are super important. They're a food source for bigger animals like fish, squid, and even whales. 14. The jellyfish. Jellyfish are another interesting creature found in the OMZs. These beautiful gelatinous animals are surprisingly tough and have adapted to live in the deep ocean's harsh conditions. Jellyfish are perfect for the low oxygen environment of the OMZs because they don't need much oxygen to survive. Their simple bodies and unique way of moving help them save energy. Instead of swimming constantly, they pulse their bodies to move through the water, kind of like gently pushing off the walls of a pool. Some jellyfish have an even cooler trick up their sleeve. They can glow in the dark. This is called bioluminescence, and they use it to attract prey, scare off predators, or even talk to other jellyfish. Jellyfish show us just how diverse life can be in the deep sea, even in places where oxygen is scarce. Their ability to thrive in these tough conditions makes them a fascinating subject to study. 15. The snailfish. Journey to the bottom of the ocean, where the pressure is immense and sunlight never penetrates, and you'll find one of the strangest creatures on Earth, the snailfish. This soft, almost see-through fish has adapted to thrive in the Hadal Zone, the deepest part of the ocean, where few other creatures can survive. They've adapted to the extreme pressure, freezing cold temperatures, and lack of food down there in amazing ways. For one, they don't have swim bladders, those gas-filled sacs that help most fish float. This helps them withstand the incredible pressure of the deep sea, which would crush most other fish like a soda can. They also have special proteins in their blood that act like antifreeze, keeping them from turning into fish popsicles in the near-freezing water. Food is hard to come by in the Hadal zone, but snailfish are resourceful. They'll eat just about anything they can find on the ocean floor, from tiny crustaceans to bits of dead stuff. Their big mouths and stretchy stomachs let them swallow prey much bigger than their own heads. 16. The tube worm. Tube worms are masters of survival in the harsh, sunless depths of the ocean. Unlike most animals that rely on food from the sunlit surface, tube worms have a unique way of getting energy. They have a special partnership with tiny bacteria that live inside them. These bacteria can transform chemicals from the vent water into food, a process called chemosynthesis. The tube worms provide a safe home for these bacteria, and in return, the bacteria provide food for the tube worms. This remarkable symbiotic relationship allows tube worms to create thriving communities in the most extreme environments. 17. The sea cucumber. The sea cucumber may not be the most glamorous creature in the ocean, but it plays a crucial role in the OMZs. These worm-like animals are the ultimate scavengers, sifting through the sediment on the ocean floor and cleaning up any organic matter they can find. They're like the vacuum cleaners of the deep sea. Sea cucumbers have a few special adaptations that help them thrive in the low-oxygen environment of the OMZs. They have a remarkably slow metabolism, which means they don't need a lot of oxygen to survive. They also have specialized respiratory trees that help them extract oxygen from the water more efficiently. And finally, some sea cucumbers have the amazing ability to absorb oxygen directly through their skin, giving them an extra boost in these challenging conditions. These adaptations, combined with their scavenging lifestyle, allow sea cucumbers to flourish in the OMZs. They play a vital role in the ecosystem, helping to break down organic matter and recycle nutrients back into the food web. 18. The comb jelly. Imagine a creature that shimmers and glows in the dark depths of the ocean, its see-through body pulsing with rainbow colors. That's the comb jelly, a mesmerizing inhabitant of the OMZs. While they might look like jellyfish, comb jellies are actually a different kind of animal with their own special skills for surviving in low oxygen areas. Comb jellies have figured out how to thrive in the OMZs. Their jelly-like bodies don't need much oxygen to work, so they can live where other creatures can't. They also have a unique way of moving, using tiny, hair-like structures called cilia to push themselves through the water. This helps them save energy in the deep sea, where food can be hard to find. Comb jellies can also create their own light, which they use for various purposes, from attracting prey to scaring off predators. While they might look delicate, comb jellies are tougher than they seem. 19. The bristlemouth fish. Believe it or not, the most common vertebrate on our planet isn't a human, or even a bird or a fish you'd see in a pet store. It's the bristlemouth fish, a tiny, shimmering creature that thrives in the vast darkness of the deep ocean, including the oxygen minimum zones. Bristlemouth fish are small, typically only a few inches long, but their numbers are staggering. Scientists estimate that there are trillions, if not quadrillions, of these fish in the world's oceans, making them the most abundant vertebrate on Earth. These little fish have light-producing organs all over their bodies, a feature known as bioluminescence. Like other creatures in the OMZs, bristlemouth fish have adapted to survive with limited oxygen. They have a slow metabolism and efficient gills that help them extract oxygen from the water. Their small size also means they don't need as much oxygen to survive. The sheer abundance of bristlemouth fish makes them a crucial part of the ocean's food web. They are a primary food source for larger fish, squid, and other predators, helping to sustain life in the deep sea. 20. The gulper eel. While many creatures in the OMZs have adapted to the low oxygen levels by slowing down their metabolism or developing specialized respiratory systems, the gulper eel takes a different approach. This bizarre fish has evolved a unique feeding strategy that allows it to thrive in the food-scarce environment of the deep ocean. The gulper eel's most striking feature is its enormous mouth, which can open wide like a pelican's beak. This allows it to engulf prey much larger than itself, making the most of any meal that comes its way. Its long, whip-like tail ends in a glowing tip, which acts as a lure to attract curious creatures in the darkness. Once a fish or squid gets close enough, the gulper eel strikes, using its expandable stomach to accommodate its oversized meal. The gulper eel, with its unique adaptations, is just one example of how life has found a way to thrive in the seemingly inhospitable OMZs. But these zones aren't just isolated pockets of the ocean. They're connected to the health of our entire planet and help in regulating our climate. 21. OMZs and climate change. Oxygen minimum zones play a big role in keeping our planet's climate stable. Acting like massive carbon sinks, they absorb carbon dioxide from the atmosphere, helping to keep our planet's temperature in check. Within these zones, tiny creatures break down organic matter that falls from the surface, releasing some carbon dioxide back into the water. However, a portion of this carbon dioxide becomes trapped in the depths, preventing it from contributing to climate change. The discovery of dark oxygen adds a new twist to this story. Scientists are now exploring whether this oxygen, produced without sunlight, might influence how much carbon dioxide gets stored in the ocean. Could dark oxygen help the ocean absorb even more carbon dioxide, or might it have the opposite effect? As our planet warms due to climate change, OMZs could change in size and location, potentially disrupting this delicate balance. We've already seen how OMZs help regulate our climate, but that's not all they do. These zones are also significant for another crucial process that keeps the ocean healthy and full of life: nutrient recycling. 22. Nutrient recycling in the OMZs. The oxygen minimum zones play a crucial role in the global ocean's nutrient cycle, acting as vast recycling centers for essential elements like nitrogen and phosphorus. These nutrients are vital for the growth of phytoplankton, the microscopic plants that form the base of the marine food web. But the low oxygen conditions in OMZs make this recycling process a delicate balancing act. In OMZs, the breakdown of organic matter is largely driven by specialized microbes adapted to low oxygen environments. These microbes release nutrients back into the water, but they also consume oxygen in the process, further depleting the already limited supply. The presence of dark oxygen, however, could potentially enhance this recycling process by providing an additional source of oxygen for these microbes. This delicate balance is easily disrupted. Changes in ocean temperature, circulation patterns, or nutrient inputs can significantly impact the functioning of OMZs and the rate of nutrient recycling. For example, excessive nutrient runoff from land can lead to algal blooms, which, when they die and decompose, can create even larger OMZs and further disrupt the nutrient cycle. Nutrient recycling in the OMZs is a vital process that sustains life throughout the ocean. However, this delicate balance is threatened by human activities, including the growing interest in deep-sea mining. 23. The threat of deep-sea mining. The discovery of dark oxygen has thrown a major curveball into the plans of deep-sea mining companies. They've been eyeing those polymetallic nodules, the very rocks that produce dark oxygen, as a source of valuable metals like cobalt and nickel, which are essential for things like batteries and electronics. The Clarion-Clipperton Zone, where dark oxygen was found, is a prime target for these mining operations. But now, with the revelation that these nodules might be vital for life in the deep sea, the stakes have changed. Environmental groups like Greenpeace are strongly against deep-sea mining, saying we just don't know enough about the delicate ecosystems down there and the potential harm mining could cause. This discovery couldn't have come at a more crucial time, as world governments are currently deciding the fate of this new industry. They'll have to weigh the economic benefits of deep-sea mining against the potential damage to the environment, including the impact on dark oxygen and the creatures that depend on it. What other astonishing secrets might we uncover, and at what cost?